Hey guys, my name is Abhishek and welcome back to MBBS Treasure Channel. Today we are going to discuss the investigation methods of hearing system or auditory system. So let's begin our today's topic. So friends, I have already discussed the anatomy, physiology and histology of different parts of ear that relates the external ear, middle ear and inner ear. Now we are going to read the different methods of investigations of hearing. And in these methods, we are going to find different disabilities related or different pathologies related with the hearing system. Okay, in this video, we are going to talk about the speech and tuning fork test. And the tuning fork test includes the Rene, Weber, and Swaba test. So in this video we are going to conclude all the results or interpretations of this speech and tuning fork test. First, the speech test. This is a test of hearing and this is a test for finding any kind of hearing loss, and it is used to measure the speech reception threshold. What is that speech reception threshold? It is the minimum limited sound, or it is the very limited sound at which we can hear the sound and recognize that sound. So it is a threshold that we are going to find of each ear through this speech test. In this method, the audiologist provides different daily activity words to the patient at different volume, and in relation with that the patient is going to hear that sound and going to analyze or recognize what words are being interpreted by the audiologist. And according to the different volume of sounds provided by the audiologist is going to find the speech reception threshold of each ear of the patient. Okay, so it is examined at different volume of sound. That means the words the audiologist is going to say. So what are the normal results that we are going to see in the speech test? At high frequency format or HF format, when the sound have highest frequency, then the normal human ear must hear the sounds of ordinary speech. The ordinary speech means at normal conversation with the people, it means that ordinary speech, the normal human here can hear around at 20-meter distance or more. Okay, so when we are going to have conversations with normal people and the distance is within 20-meter, then we are going to hear the words and we are going to recognize those words. And even more also, if the distance will be more also, we are going to recognize those words. But if there will be distance, if the distance will be less than 20-meter and we find that the person or the patient is unable to hear even if the distance is less than 20-meter at ordinary speech, then we think about that the patient is having some kind of disability with his ear and with listening or hearing of his ear. Next, with low frequency format. Low frequency means when the frequency of the sound waves have low frequency, then at that moment the normal human ear must hear the sounds of whisper speech. Okay, it means the whisper speech have the low frequency and the ordinary speech have the high frequency format. So at whisper speech, the person is going to normally the person is going to hear those whisper speech also at 5-meter distance, and these 20-meter and 5-meter are the minimum values or minimum normal values that we are going to find in the speech test. And if the normal value, if the value comes below this normal value, then we are going to conclude that yes, the patient is having some kind of hearing loss. Mixed format means it is perceived with distance of 12.5 meter. If we are going to calculate the average distance perceived by the ear at a normal human ear, then we are going to find the mixed format. It means the mixed frequency of sound waves having both high frequency and low frequency format. So these are the conclusions of the speech test that we are going to find. In speech test, you have to remember the ordinary speech is represented as CS, letter capital C and S, and whisper speech is represented as capital W and S. These are important because these short abbreviations of ordinary speech and whisper speech is going to help you while calculating or while analyzing the audiogram passport. We will be reading about that audiogram passport in this Rene, Weber and Squaba test. Okay. So next we are going to read about the tuning fork test. As I have said that it includes these three test methods, and these three test methods includes the instrument that is tuning fork. What is that tuning fork? Tuning fork, it is an instrument that is used to produce or generate the sound waves. Okay, it produces the sounds at a certain frequency. Okay, so there are different kinds of tuning fork that produces the sounds at a particular frequency. So there are many kinds of tuning fork, and it starts from C128, or it starts from 664 and till 4096 Hz or 4096 Hz. In the tuning fork test, we specifically used the low frequency tuning fork, that is C128. Okay, 128 Hz frequency is used for analyzing this test. Then the tuning fork test, what is the main reason that why we choose this instrument? Because this instrument will help us to compare the perception time with this instrument C128 low frequency through bone and air. It means that we are going to calculate the sound conduction time in bone and air through the instrument, that is tuning fork, and the tuning fork will help us to compare this perception time of bone and air. So normally, physiologically, the sound conduction is more efficient via air than via bone. It means that the conduction time through the air is 2 times longer than the bone conduction. What do you mean by this? The time taken for the conduction of sound wave through the air is 44 to 45 seconds, whereas the time taken for conduction of this sound wave through the bone is 21 to 22 seconds. It means the sound persists much more longer in air or through air than bone, or twice or 2 times longer than bone conduction. This means that if this is the external ear and the sound wave comes in the air and it is conducted through the air and through the external acoustic meatus towards the tympanic membrane. Surrounding the external acoustic meatus, or surrounding the pinna or external ear, we have the temporal bone, and inside the structures of temporal bone we find the middle ear and inner ear. So the whole ear structures are surrounded by bone. So we can also assume that some sounds are also conducted through the bones. When the sound wave comes nearest to the bone that are surrounding the structures of ear, then there will be production of the vibration inside the bone, and that vibration spreads along this direction towards the middle ear cavity. That is also going to generate some kinds of vibrations inside the ear ossicles that are present inside this middle ear. So that vibration, or the time taken for the vibration to spread through the bone that are surrounding the structures of ear, takes around 21 to 22 seconds. So it persists much smaller time than through air, or it persists half time than air. So we can conclude that the conduction time through air is 2 times longer than bone conduction. It means the air conduction is better 2 times than the bone conduction. Then what are the possible interpretations or the results of the tuning fork test? the tuning fork test, through tuning fork test, we can analyze different kinds of hearing loss or deafness. Okay, so the hearing loss and deafness can be of three types. It can be conductive hearing loss or deafness, or sensory neural hearing loss, or it can be both or mixed. That means both conductive and sensory neural hearing loss. What is conductive hearing loss? Conductive hearing loss means the obstruction of external acoustic meatus or the external auditory canal or disease of the middle ear, that is otitis media, and it leads to impairment of the middle ear. When the conductive hearing loss will happen, or when there will be conductive hearing deafness, then the external ear and the middle ear will be affected, and the conduction through the ear ossicles will be affected, and that results in impairment of the middle ear. We can conclude that if there will be any kind of problem relating with the middle ear, then we are going to find the conductive hearing loss. If sensory neural hearing loss, it means the disease affecting the cochlea and cochlear nerve of inner ear. These two structures that are present in the inner ear, and when there will be disease or any kind of pathology relating to the inner ear, then of course it is going to impair the inner ear functions. And from this we can conclude, if there will be any kind of pathology present inside the inner ear or any kind of impairment of the inner ear, then we can find this sensory neural hearing loss. Next, it can be both mixed. It means that both conductive and sensory neural hearing loss can be present. So this is the structure of ear. This is the external ear, middle ear and inner ear. If there will be any kind of problem in the middle ear, then we are going to conclude that it is conductive deafness or conductive hearing loss. If any kind of problem relating to the inner ear, then we are going to conclude it as sensory neural hearing loss or sensory deafness. So these informations should be kept in your mind, because through these informations only we are going to analyze the results of each test. Okay, so the relation between the middle ear and the conductive deafness and inner ear and sensorineural deafness should be remembered.